In this video, I want to have a look at a classic paper, came out around 1950 by the great and early computer scientist and thinker Alan Turing. It's called Computing Machinery and Intelligence. It's a landmark paper. Many of Turing's papers, in fact, were. He's a groundbreaking thinker. And of course, many of you have heard of the movie, no doubt, The Imitation Game. Well, that's section one of the paper is called Imitation, The Imitation Game. The paper is broken up into a number of sections, and I'm going to go through them. And by no means am I going to exhaust this paper. It's a very rich and interesting one, and it's largely a philosophical discussion. There's some history of computer technology that's interesting, although it's largely of, I think, antiquarian interest. So I'm not going to go into all that, but I want to pick up on some of the philosophical points. Now, the whole thing is really organized around the question of whether or not machines can think, but it's Turing's attempt to replace this question with a different kind of question that he thinks is actually as important, if not more important, and something that we can get a grip on. Okay, so the imitation game, Turing starts off by saying, look, here's the traditional question. Can machines think? He wants to replace that question because he thinks it's a little too vague. He said, we'd have to define all our terms, like what is thinking. These are vague terms, very difficult to get. We may use these terms, but it's very difficult to get a grasp of them and put them out in a nice, easy definition that we would all at least agree on. Probably won't have any luck with that. How do we figure this out? Should we be taking polls? How do we determine whether or not computers can think? So he thinks that the normal attitude towards words can be rather dangerous. And so he thinks that ultimately this traditional question, he more or less dismisses it. He thinks it's really too vague and ultimately meaningless. So there's a lot going on just in the opening passages of this paper where Turing is dismissing a lot of traditional thought because he wants to replace it with what he thinks is a better way to address this issue of thought outside of the human mind, thought in something like a computer or a machine. How are we going to approach that problem? He doesn't think that's a good way to go. So he wants to replace this traditional question with something else, and namely this kind of a game he calls the imitation game. And so this it addresses sort of the spirit of the question, like can thought exist outside of the human mind? Can it exist in other places? And what does it mean? How would we determine this? And so this is in the long tradition of thought experiments in philosophy and thought experiments in science. Einstein did his thought experiments imagining he was riding on a light beam. Isaac Newton, performed thought experiments about, universes with only two masses in them, or a universe with no mass, to think about what would happen if you basically had one mass in a universe and threw it, and what would happen, what would it do? And he imagined these situations to try and come up with laws. So thinkers, such as scientists or philosophers, using thought experiments, nothing new there. So in that sense, Turing is right out of the philosophical and scientific traditions when he says, I want to address a problem via a thought experiment. Pretty old stuff, but an interesting one at that. So this thought experiment is what he calls the imitation game. So now there's a variety of ways to describe it, and I'm just taking a very simplistic view. Okay, so you start off with it's human beings playing this game. There's three people playing it. There's an interrogator indicated by letter C, and a man and a woman. So man A, woman designated by letter B. However, the interrogator doesn't know that it's a man or a woman, and it's just known by C as X and by C as Y. And it's the interrogator trying to figure out who's who, which one's the man, which one's the woman. And the man has a goal, right? He's trying to get C to make mistakes, right? So the man can lie and do all kinds of things. And the woman's goal is to get C to get it right. Now, you might think something as simple as, well, the woman could just say to the interrogator, well, the other one, I'm the woman, and the other one's a man. But since the interrogator is blocked from seeing everything, they're just communicating, let's say, through pieces of paper or electronically or whatever. So they can't see each other. So it's just text-based communication. They could be texting each other. Of course, Turing didn't have that, but we could think of that in a modern sense. So you don't know who's on the other end of the text. All you have is the text, and you can just say, oh, that's text from X texting me or Y texting me. The interrogator doesn't know, and you got to figure out which is the man, which is the woman. And of course, the man can lie, right? He can say, well, you know what, I'm the woman. And so who do you trust? So how could you figure out? So basically, you just imagine this game as going over, and eventually the interrogator, after so many tries, would then say, well, I think that X is the man or the woman, and Y is the woman or the man. So the interrogator plays this game with X and Y, has to come to some conclusion. So Turing says something like this. It's a pretty simple game. Imagine this going on and on and on. And so, like, imagine that if humans all playing now, play this imitation game Z times, whatever, like a big number of times, several times. And how often, like, let's say they run the game and the interrogator, does the guess or the, whatever, says, I think one, which is which. And then we do this repeatedly. And then you keep track of how often that C would get it, the interrogator would get it right or wrong. So let's say it's Q% of the time that it, so many times out of the total, Q represents the number of times that C is wrong. Okay, so you take that, then you take the person out here and you replace a machine in. Okay, so this is the imitation idea of imitation. Suppose that you put a machine in now, takes the place of A, and then you program the machine to try and get C to make mistakes and whatever, to say all kinds of things, and then you run it again the same number of times. As we did it with the humans, Z times, so you run the imitation game Z times again. And then so there's the interrogator's a person, and the other, woman here and the computer here. And then you ask yourself, what will be the results, right? So we knew when we run it with humans, C is wrong Q% of the time. Will C be wrong Q% of the time when A is a computer? And so what Turing says is that he wants to replace this traditional question, can machines think, with this question here. Will C's answer be better or worse when A is a machine versus A is a human? So when the interrogator is trying to figure things out, what does the track record of the interrogator look like when it's only humans playing versus when we stick a computer in for one of the humans? Turing thinks this is the way to answer the question or the problem of whether or not thought could be, and thinking and thoughts could be inside of a computer, rather than just say, well, can machines think, right? He doesn't think you're going to get anywhere with that question, but he thinks this one will give you some traction or some way of addressing that question. Now, Turing, of course, he knows full well that a lot of people are going to have some problems with this. And this Turing test has been discussed, ad nauseum, right? And for good reason. It's a highly speculative, highly interesting question. And in part two, so there's you go. Part one is the imitation game. Part two, he does a little. He starts his critique and his analysis. Namely, is this new question, right, down here, because remember, he replaces the traditional with the new question, is it worth investigating, right? It separates appearances from intelligence. It aims at separating intelligence in the abstract from practical demonstration. He wants to make sure that machines, that we're not prejudiced against them because they don't look like us or whatever. So he wants to abstract the whole notion of intelligence from what we're normally used to seeing it in human beings, right? So he thinks that the imitation game, it liberates us from certain prejudices that would normally, oh well, that can't be thinking over there because it's just a box on a tabletop, so it can't be thinking. No, we want to try and get away from that. So the imitation game allows us to shed some of our prejudices. So he thinks that's a good idea. Um, but Turing, he admits that there are a number of objections, but he says that, we might be able to construct a machine that plays this imitation game very well. Now, he doesn't really spend a lot of time on whether or not this is a worthwhile question or whatever. He just thinks this is the way to go. And he doesn't talk much about the theory of this or anything. He just really wants to get on with this and examine some issues in computer technology. And then eventually he's going to look at a number of criticisms of the idea of putting thought anywhere else in a human mind. But this is the basic start. So the whole thing is to shift away from this sort of abstract question of can machines think, but a different kind of abstracted context, namely away from attributing thought from ourselves or our prejudices as to where thoughts should be, and just in terms of a game of whether or not, and you think of it, that a computer could function in a community and not be able to, and wouldn't give itself away as it was trying to function in a community. So what we'll look at in the next video or two is some of Turing's commentary, which is quite interesting on the ramifications of taking the imitation game seriously.